Hello everyone, in this video I will talk about partial fraction in calculus, how to calculate the integral. Okay, so for example you have the integral which is a fraction, for example 1 over x plus 1, right, x minus 2 dx, right? So how can you solve it? Okay, it's not easy to solve it. You cannot use substitution, you cannot use trigonometry substitution. So the only way to do it is use partial fraction. Okay, so what is partial fraction? So you see, if a fraction inside right here, if you can split the fraction to two fractions, for example, if you can split it into the integral of, for example, a number a, right, a random number a, over x plus 1, for example, like this, plus the integral of b over x minus 2 dx. This is dx, right? If you can split it like that, you can easily compute the integral, because this integral is a natural log of x plus 1, right? And plus this is natural log of x minus 1, right? Plus c. So it would be easier if you can use partial fraction, alright? So how can you find a and b, right? So our integral is 1 over x plus 1, right? X minus 2 dx, right? And equal to a x plus 1, right? Plus b x minus 2 dx, right? So how can you find a and b, right? So first I'm gonna group these two fractions together, right? So that actually equal to a x minus 2 plus b x plus 1. This is x plus 1, this is x minus 2 dx, right? So next one, that's equal to ax minus 2a, right? Plus bx plus b over x plus 1, x minus 2 dx. Okay, so this is the original integral, right? And this is the integral we want to make, right? So you see the bottom of the original integral is the same at the bottom of the result, right? And the top, we need to balance the top. We need to make the top equal to the top of the original. So we need to make one is the top of the original integral, right? We want to make it equal to the top of the integral we want to make, right? So this is ax minus 2a plus bx plus b, right? So that equal to, x term, we're going to group x term together. So we're going to have x a plus b, right? So 2a plus 2b, right? So you know that this is binomial function, right? So we have to compare the coefficient of each term, right? So this is constant. 1 is constant term, right? And so it's supposed to be 0 plus 0 minus x, right? 0 minus x is 0, right? So, x term, we need to compare x term and x term, constant term and constant term, right? So, x term of the left hand side is 0, and x term of the right hand side is a plus b. So we're gonna have a plus b equals 0. Yes, and we need to compare the constant term, right? So constant term of the left side is 1, and constant of the right side is this one. So we're gonna have 2a plus b equal 1, right? So now we're gonna solve for, we have a system of equations, and we're gonna solve for a and b, right? So first equation, we're gonna have a equal negative b, right? So we're gonna substitute a equal negative b back to the second equation. So we're gonna have negative a, negative 2, a is negative b, right? So negative b plus b equal 1. So we're gonna end up with 3p equal 1 and p equal 1 over 3, right? Which means a equal negative 1 over 3. Okay, so the integral gonna be the integral 1 over x plus 1, x minus 2, the x gonna be, a x plus 1, right? Plus b x minus 2, right? The x. So a is negative 3, so it's essentially negative 1 over 3 x plus 1, right? Plus b is 1 over 3, so 3 is x minus 2 dx, right? So you can easily compute this integral because that one equal to negative 1 over 3 natural log of x plus 1, right? Plus 1 over 3 natural log of x minus 2 dx. Oh, not dx anymore, sorry. Plus c. Okay, so this is the result of the integral, right? So this is partial fraction. Okay, so next one we're gonna do another example. Okay, so for example, we have the integral x plus 5 over x squared minus x minus 12 dx, right? So first we can factor the bottom. So the bottom equal to maybe x minus 4, x plus 3. Yeah, the bottom equal to this one, right? The x. Okay, so we need to use partial fraction so that we're gonna split this function into two functions, right? So the integral will be a over x minus 4 plus b over x plus 3, the x, right? So the integral gonna be a x plus 3 plus b x minus 4, x minus 4, x plus 3 dx, right? Okay, so we have the bottom and the bottom is the same, right? So we're gonna compare the top. So this is the top of the original, right? And this is the top of the integral we're gonna make, right? So we're gonna let that two of them equal each other, right? Because we want to compare them. We want to make them equal to each other, right? So we're gonna have x plus 5 equal a x plus 3 plus b x minus 4, right? So that is equal to ax plus 3a plus bx minus 4b. Okay, so we're gonna group the x term together. So a plus b and group the constant together, 3a minus 4b, right? So you see that at the left, the coefficient is 1. The coefficient before x is 1. The coefficient before x of the right hand side is a plus b, right? So the first equation is going to be a plus b equal 1, right? And another one is, this is constant, right? Like free coefficient, right? So that one equal to 5. And we need to solve for a and b from this system of equation. So from here we're gonna have a equal 1 minus b, right? We're gonna substitute it back to the second equation, so we're gonna have 3 1 minus b minus 4b equal 5, right? So this 3 minus 3p minus 4p equal 5. So that is 3 minus 5 equal 7p, right? So p equal to negative 2 over 7, right? Which means a equal to 1 minus b. 1 minus b is So that is plus 2 over 7, right? So it's equal to 9 over 7. So we have a equal 9 over 7 and b equal negative 2 over 7, right? So the interval x plus 5, x plus 5, x squared minus x minus 12, right? Equal to x plus 5, x minus 4, x plus 3, right? dx, right? And that equal to a over x minus 4, right? Plus b over x plus 3 dx, right? So we already found that a equal to 9 over 7 and b equal to negative 2 over 7, right? So that equal to negative 7 x minus 4. 9 over 7 x minus 4, right? Plus b is negative 2 over 7 x plus 3 dx, right? So this integral equal to 9 over 7 natural log of x minus 4, right? Minus 2 over 7 natural log of x plus 3, right? Plus c. Okay, so this is how you use partial fraction to evaluate the integral, right? So this is our final answer. Okay, so if this video is helpful, don't forget to give me a like and subscribe. Thank you.